Hello dear students, today we will be discussing about graphical representation of motion. Okay, you have learned about different types of graph in mathematics. What are they? For example, bar graph, pictograph, line graph. All these graphs you have learned in the mathematics. Okay, and what is the speciality of line graph? Why we are using line graph? Solve the linear equations, we will be using line graph. Why we use a line graph in that? Means in the linear equations you have learned that there are constants and variables. And variables are of two types. What are they? Dependent variable and independent variable. So in this situations we will be using the line graph. And here when we are dealing with the graphical representation of motion, we will be using the line graphs. So as you know, there are two axes. What are they? X-axis and Y-axis. Why we use an arrow mark here? Because it's a line segment and we can extend it. That's why we are using arrow mark. And this axis is X-axis and that is horizontal axis because it is a horizontal line. So we are saying that X-axis is the horizontal axis and this is a vertical line. So Y-axis is a vertical axis. Okay. And what is this point? This is the origin. Okay. O is the origin. So all these three things you know, X-axis, Y-axis and the origin. And you know we will be choosing a suitable scale according to our convenience. Is it? Yes. So when we deal with the graphical representation of motion, there are different types of graphs. And the first one is distance time graph. Distance time graph. See, in this case, can you see the variables? There are two variables here. What are they? Distance and time. And which variable I will be taking in the x-axis? Either distance or time. I have to take time along the x-axis and distance along the y-axis, because with respect to time, the change in position of an object is calculated. With respect to the passage of time, we will be calculating the distance of an object. That means time is an independent variable and distance is a dependent variable. So independent variable will be taken along the x-axis and dependent variable is taken along the y-axis. Clear? So distance and time, and we have to mention the unit. Okay. So suppose I am taking time in second and distance in meter. Okay. I am calculating the position of an object in meter. Okay. In situation, so here the time is 0 second and here 1 second, 2 second, 3 second, 4 seconds. So I have taken a scale like this, that is in the x-axis 10 division is equal to 1 second. And in the y-axis I am taking, this is 0 meter. Okay. You know that. And 2 meter, 4 meter, 6, 8, 10. That means in the y-axis what's the scale I have taken? 10 division is equal to 2 meter. Okay. So hope you understood till here. And I am going to draw a graph here. I have got a straight line graph. And what's the speciality of this graph? This straight line is parallel to x-axis. Okay. This straight line is parallel to x-axis. How we will be plotting a graph? I'll be having the position of an object. Okay. So at 1 second the position of an object is at 4 meter and at 2 seconds the position of an object is at 4 meter, and at 3 seconds position of an object is at 4 meter, and at 4 seconds the position of an object is at 4 meter. We can say that the position of an object does not changes with respect to the passage of time. The time is passing 0 second, 1 second, 2 second, 3 second, 4 second, like that. But the position of an object does not changes. From the origin, the object is at a distance of 4 meter. From the origin, with respect to the origin, the object is at a distance of 4 meter at the initial stage. That means at 0 second, the position of the object is at 4 meter away from the origin, and it continues as the time passes. Okay, so we can say that the object is at rest, or the object position of the object does not changes in this case. Okay, or we can say that the object is stationary. Stationary means what? It does not changes its position with respect to the passage of time. Okay, so if we are getting a graph like this, that means parallel to x-axis, then we can say that the object distance time graph, if we are drawing, then we are getting a straight line graph like this. Then the position of an object does not changes, or the object is at rest, or we can say that the object is stationary. Understood? When we deal with the position of an object changes, that could be uniform motion or non-uniform motion, as we have learned, is it? So I will be drawing another graph. I will be plotting x-axis and y-axis, horizontal axis and y-axis, and I write O here, that is origin. And I'm taking again distance time graph, so I'll be taking time in second itself. Let me take time along the x-axis and distance along the y-axis, distance in meter, okay, along the y-axis. And I'll be taking 2 second, 4 second, 6 second, 8 second, like that. Okay, so here I have taken 10 division is equal to 1 second, and here I have taken 10 division is equal to 2 seconds. As I have said, scale can be taken according to our choice. Okay, and with respect to the question, we can choose any scale. Okay, and here I am taking, this is 1 meter, 2 meter, 3 meter, 4 meter, like that. Okay, and if I plot the graph, if I get a graph like this, okay, if I get a graph like this, that means here also I have got a straight line graph. And what is the speciality of this graph? It is moving with a constant angle. Here there is no slope. Okay, this is making an angle with the x-axis. Okay, and it's a straight line graph. Then how can we say the motion of an object in this? How can we say the change in position of an object? Yes, this is in the case of uniform motion, or if the object moves with constant speed, then we will be getting a straight line graph making an angle with the x-axis. How can we say like that? Yes, let us take 2 points. I will be considering 2 points, that is A and B. Okay, and from A I have extended it to x-axis and y-axis, And here also, from this point also, I have extended this to x-axis and y-axis. Okay. And if I extend this line, I will be getting another point that meets at C. Okay. And if you see this part, I'll be getting a triangle. Triangle ABC. Clear? Understood? And here I will be taking this time. That means the object is at A when the time is T1. And the object is at B when the time is T2. Okay? And here the object is traveled a distance of S1 when S is normally we will be using for distance. So S1 is the distance when the object is at A, and S2 is the distance when the object is at B. So if you are calculating the slope, you have learned how to calculate the slope, and slope is equal to y divided by x. And in y-axis what we have taken? Distance. And in the x-axis what we have taken? Time. That is, we will be getting distance divided by time. Is it? Distance divided by time. What is that? Yes, we have learned. That means we can calculate the speed of an object from this graph. Okay, distance by time. If you are taking the slope of this graph, you will be getting the speed of an object, okay, at a particular distance. Okay. So how can we calculate the speed? Let us see that. Okay. The speed is equal to, what is distance? The distance is the difference between these two, is it? That is, BC is the distance. How can we calculate BC? The BC is equal to S2 minus S1. Is it? This is the distance travelled. Okay, that is BC. And next, how can we calculate the slope? Y by x. Y-axis is this BC. Then this is AC. AC, how we will be getting? T2 minus T1. That means the time duration. So, S2 minus S1 divided by T2 minus T1. Okay, if I take here, I will be getting S2 minus S1, that is 3 meter minus 2 meter, that is 1 meter divided by T2 minus T1, that is 2 seconds. Okay, 1 by 2, or we can say that 0.5 meter per second, or ms raised to minus 2. That is the speed of the object in this case. Is it clear? Okay, so we have covered two types of graph in this distance time graph. The first is the object is at rest, or the object is stationary, and here the object is moving with a constant speed. Okay. Okay. And instead of distance, if we are taking the magnitude of displacement, that means if you are drawing the displacement time graph and we are getting a graph like this, then what can we say that? We can say that the object moves with, here instead of speed, what we'll be getting? In the y-axis, we are taking the magnitude of displacement. So displacement by time is velocity. So we can say that if it is a displacement time graph, we will be getting the same graph. If it is, then we can say that the object moves with constant velocity. So instead of distance, if we are taking the magnitude of displacement, then and the time, with respect to time, the displacement of an object changes uniformly, then we can say that the object moves with constant velocity. Here we can say that with respect to time, the distance of an object changes uniformly. Okay, in 2 seconds the object traveled 1 meter, and in the next 2 seconds again the object traveled 1 meter. So we can say that the object travels 1 meter in every 2 seconds. Is it? If you see this, you can say that the object travels 1 meter in every 2 seconds. Okay. So we can say that this is a uniform motion and the object moves with uniform speed. Is it clear? Thank you.